Hello my dear students, welcome everyone. Now let's start the second part of preparation of aldehydes and ketones. Okay, and the first reaction is Stiffen Reduction. So remember the techniques. Okay, so by Stiffen Reduction, cyano group of aliphatic or aromatic will change into aldehyde group. Aliphatic or aromatic cyano compound will change into aldehyde group. During this reaction, there is one intermediate is formed. That intermediate is very important for entrance. Amines intermediate. This is a reduction, and during reduction there must be some reducing agent. In organic chemistry there are lots of reducing agents, but in this reaction the most applicable reducing agent is tin dichloride and concentrated hydrochloric acid mixture. Whenever you mix tin dichloride and concentrated hydrochloric acid, it furnishes nascent hydrogen, which is actually responsible to undergo the reduction. So how to remember it? By Stiffen reduction, aliphatic or aromatic cyano compound directly change into aldehydes. During this reaction, one intermediate is formed which is called imine. The reducing agents tin dichloride and concentrated HCl. So remember only this. Now the reaction is listen the technique, okay? Whenever you write the reaction, don't write the CN group, rather write the structure of CN group. This is methyl cyanide. It's aliphatic compound. Why? The functional group of carbon of cyano group is not attached to benzene directly. That's why it is aliphatic. When you mix tin dichloride and concentrated hydrochloric acid, they furnish nascent hydrogen. Which is responsible to undergo the reduction. What is the technique? Instead of 3 bonds, write 2 bonds in between carbon and nitrogen. But you know that carbon possesses tetravalency. 3 valencies are fulfilled here. So put hydrogen to fulfill the tetravalency of carbon and trivalency of nitrogen. This is called imine. Imine is a functional group similar to aldehyde, ketone, carboxyl acid, oxime, etc. This is also functional group. This is imine. But this is a compound, so it should have some name. How to write the name? Follow the technique. When imine undergoes acid hydrolysis, again follow technique. Acidic medium, water is a reactant. Break it. So you get acetaldehyde. How to write the name of the imine? Imine is the derivative of aldehyde. So to name imine, listen the technique. Just cover it. So you see this is acetaldehyde. 2 carbon atom aldehyde is called acetaldehyde. So this is the imine of acetaldehyde and it is called acetaldimine. Imine of acetaldehyde, acetaldimine. Now the next reaction. Try to write the next reaction, okay? This is cyanobenzene. Okay? Can you write its IPC name? In case of IPC name, the cyano group is called nitrile. So it is benzene nitrile. IPC name is benzene nitrile. Remove one bond from the triple bond. Fulfill the tetravalency of carbon by putting hydrogen. Fulfill the trivalency of nitrogen by putting hydrogen. This is imine. This is not name of the compound, okay? This is a functional group. What is the technique? Just break the double bond. Break it. You get benzaldehyde. So this is the imine of benzaldehyde. That's why it's called. Just remove the EHYDE. EHYDE remove. So it is called benzaldimine. Just remove this imine, benzaldimine. Remember it, imines are the derivatives of aldehydes. So how to write the Stefan reduction? When aliphatic or aromatic cyano compounds undergo reduction in presence of tin dichloride and concentrated hydrochloric acid, imine is formed as intermediate, which on acid hydrolysis gives aldehydes and ammonia as byproduct. Can you balance it? You have entered 2 hydrogen atoms here. So put 2 to balance. Now let's write the definition of Stefan reduction. So write down the definition, okay? So this is the Stefan reduction, okay? Now next topics, using of a special reducing agent, that is di-bul-H. Remember it, in organic chemistry there are some strong reducing agents such as lithium aluminium hydride, sodium borohydride are used. But the problem is there. What's the problem? Let's check. So remember it, preparation of aldehydes and ketones are going on, okay? Preparation of aldehydes and ketones are going on. Now the next, this is the very important for board as well as entrance. See, both are used as strong reducing agent in organic chemistry. Lithium aluminium hydride as well as sodium borohydride. But can you tell me which is more stronger reducing agent? Yes, lithium aluminium hydride is stronger reducing agent because lithium aluminium hydride is stronger reducing agent than sodium borohydride, as lithium aluminium hydride can reduce ester or cyano group to aldehyde. Sodium borohydride cannot reduce ester or cyano group to aldehyde. But what is the problem by using lithium aluminium hydride as reducing agent? The problem is that it can also reduce the side chain if it contains double bond, nitro group, etc. That's the problem. See. This is the compound. The compound contains a cyano group as well as double bond. Lithium aluminium hydride, being strong reducing agent, reduces cyano group into aldehyde. So, lithium aluminium hydride easily converts the cyano group into aldehyde. But the problem is that lithium aluminium hydride is so strong reducing agent that it can reduce the cyano group along with the double bond. The double bond also is reduced. So we cannot use lithium aluminium hydride during the reduction of cyano group or ester group to aldehyde if there are any side chain such as double bonds or nitro group. In this case, a selective reducing agent is used, which is called dibal-H. See the structure, what is its function? Very important for this year in board as well as entrance exam. Its full form is diisobutyl aluminium hydride. Its structure is not given in NCERT, so see the structure. Don't write, understand it only first. Methyl, ethyl, propyl, butyl. This is the butyl group. These are the terminal carbon atoms. These are the middle carbon. If you enter any substituent at any of the middle carbon atom, it's called isobutyl group. Iso comes from isomers. It is aluminium hydride. Aluminium possesses trivalency, hydrogen and hydrogen. If you replace any two, this or this, two hydrogen atoms by two isobutyl group, then let's check. So we substitute two hydrogen atoms by two isobutyl group. Fulfill the tetravalency of carbon by putting hydrogen. This is the structure of diisobutyl aluminium hydride. This is the structure of diisobutyl aluminium hydride. Very important, okay? I think you understand it. What is the use of diisobutyl aluminium hydride during reduction? Listen. So, di-BAL-H easily reduces ester group and cyano group to aldehyde without reducing nitro group or alkene double bond if they are present in the compound. But you know that lithium aluminium hydride can also reduce ester and cyano group to aldehyde, but the problem of using lithium aluminium hydride is that it also reduces the side chain if it contains nitro, alkenes or any reducible functional group. This type of reductions called selective reduction. Okay, now see the examples of selective reduction. This compound contains one cyano group and one double bond. If you use lithium aluminium hydride, it reduces the cyano group to aldehyde, but it also reduces the alkenes. That's why we cannot use here lithium aluminium hydride. We should use dival H. Two-step process. At first use dival H, then acid hydrolysis, or simply put water. The cyano group will change into aldehyde group at the same time. It has no effect. The double bond remains as it is, but if you use lithium aluminium hydride, it also reduces the double bond. Another example,